Knowing how to convert between degrees and radians is vitally important, but there is a set of angles that you're going to use over and over again that it's important for you to be able to quickly know the relationship between degrees and radians. Specifically, we're going to look at a 30-degree angle, a 45-degree angle, a 60-degree angle, and a 90-degree angle. These are all angles that you deal with commonly, but let's look at what they're going to be in radians. Again, each of these will be converted by multiplying by pi over 180. And we are not going to put these in decimal form, but rather convert them in fraction form. We get pi over 6 is 30 degrees, pi over 4 is 45, pi over 3 is 60, and pi over 2 is 90. And this one is kind of the base that I use for everything. Remember, we know that 2 pi goes all the way around the circle. So if I'm just doing 90 degrees here, if 2 pi goes all the way around, I'm dividing that essentially by 4, which becomes pi over 2. And that sort of helps me work back to the other picture of what's happening here. These angles are become very important in terms of triangle relationships that we're going to deal with shortly. So let's consider a triangle that has two 45-degree angles. Remember, 45-degree angles are going to be pi over 4 in radians. And in that unit circle, if we go back to this, remember each of these is going to be 1. And based on the Pythagorean theorem, 1 squared plus 1 squared is going to equal 2. But we know that that's a squared plus b squared equals c squared. So c is going to be the square root of 2. And that tells us that the ratio between the legs of a triangle that has two sides that are equal is going to be 1, 1 square root of 2. Likewise, for a 30, 60, 90 triangle, if we consider a triangle that's 90 degrees and then 30 degrees and 60 degrees in that unit circle, let's put its mirror image in here. So this is also 1. Again, picture the unit circle. So we know that this relationship is also 1. I'm sorry, that relationship will be 2 because we're dealing with, we've doubled that base there. And so this relationship, using the Pythagorean theorem, if we call this A, we've got a squared plus b squared, which is 1, plus c squared, which is 2 squared. And so we can calculate that a value. A squared is going to be 3, so a is the square root of 3. So the relationship on a 30, 60, 90 triangle is going to be 1 to 2 to the square root of 3. If you have trouble remembering that, just remember of which one goes where. Remember, first of all, 60 is pi over 3. So we have pi over 3. This is going to be pi over 6. We know this is 1 to square root of 3. If you can't remember which one goes where in terms of those relationships, remember that we have pi over, I'll make this a little bit bigger. If we have pi over 3, which is 60, pi over 6, which is 30, and this is 90. 90 is the biggest, so it's going to have the biggest number, which is 2. 30 is the smallest right here. It's going to have the smallest length opposite it, which is 1. And then square root of 3 is between. So angles are always opposite the side that holds the same relationship. But that 1 to square root of 3 is going to become vitally important when we start dealing with trig relationships. Let's use some of these relationship ideas to determine radian measure. For example, if you have the unit circle, and let's suppose we want to calculate in radian measure the value of this theta. First of all, we know it's going to be positive, and we know from here to here, that's going to be 180 degrees, which is just pi. But then we have this additional relationship, which we can turn into a triangle. Because it's the unit circle, we know the radius has a value. And actually, I'm going to redraw my circle here for you. It's going to be the same shape, but I want to make it a little clearer in terms of if I draw my line out like this, and my circle is inside of that, so to speak. So we're still looking for this angle. We know this distance here is still pi, but we can drop our triangle down, and we know that this value is 1 and this value is 1. Well, from what we just discovered, this relationship tells us that this angle right here is pi over 4. So we know that this is pi plus pi over 4 results in that theta being 5 pi over 4 that goes all the way around. Don't forget that angles can go around over the amount of 2 pi. So for example, if I have my unit circle here, and let's suppose that I start here and I travel around and back, where this is my angle. So clearly I've gone around at least one full circle, which is negative 2 pi, because remember I'm traveling clockwise. So that's from here to here. And then I've traveled even further from here to here, which is another negative pi. And then I need to extend it just a little bit more by this amount right here. Well, let's pull down that triangle. If you were to label this, this actually comes out to 1/2, and you would see that marked off clearly on a graph. We know that this is the radius, which is 1. And so this is half of that. And remember from our triangles before that 1 to square roots of 3 ratio tells us that this angle that has traversed from here to here, this is going to be pi over 6, which tells us that this extra amount, pi over 3, not pi over 6, sorry. We continue with our pi over 3, the total distance that's covered, if we get a common denominator, that adds up to negative 10 pi over 3. So we've gone around a half a circle and then an additional pi over 3 radians.